Okay, in this presentation, we're going to look at the differences in Poisson rates. So, the bank robberies in various countries are assumed to occur according to Poisson processes with rates that vary from year to year. It's reported that the number of robberies in a particular country in a specific year was 223. The number of robberies in a different country in the same year was 111. Now, it can be assumed that each robbery is an independent event and the robberies occur independently in the two countries. Determine a 95% confidence interval for the difference between the true yearly robbery rates. Okay. Now, so this is essentially, first off, actually, let's just sort of start this up. Okay. What we're looking at here is we have the rate in one country, okay, versus the rate in another country. And if we were to approximate that, we would use this expression here, noting that the mean and the variance are both equal to lambda in both cases. Okay, now, this is a sort of peculiar one. If you're sort of familiar with any of these other videos, that you might sort of think note the sampling distribution. Okay, now, this is a particular variation of it, because if you read it in this, you sort of see what we have to work with. Okay, so we have 123 in one country and 111 in the another country. Okay, so lambda hat 1 equals 1, 2, 3, and lambda hat 2 equals 1, 1, 1. So, sorry, just actually as a remark, it's yearly robbery rates. Okay, so this is the sample size, essentially a year. Okay, so that's what might throw us a bit if we're sort of looking at this and thinking, hold on, don't we need sample size and stuff like that? We get them. It's just equal to 1. Okay, so that's why the sampling distribution in this case is a little bit unusual. So correctly, I could go over lambda, when I'm writing the variance, lambda 1 over n1 plus lambda 2 over n2, but essentially because the sample size is just 1, that's what we end up with. Okay? So that's the sort of the key thing actually really about it. It doesn't feel satisfactory, but we just got to work with what we have to work with. Okay? So, and we end up with a fairly wide interval considering this sort of data. But that's just the way it goes. So, anyway, the point estimate is the difference between the two. Okay? So it's 123 minus 111, which is 12. Okay? So, there seems to be a 12 more robberies, according to this estimate, per year. Okay? This is our confidence interval, so that's our point estimate. That's our quantile for a 95% confidence interval, okay? And this is our standard error. And again, just to remark, when we deal with sample size of 1, this is what we have to work with, okay? We're working on a yearly basis. I keep harking back to that point, but this is sort of the key thing about this. So essentially, the standard error is the standard deviation of the sampling distribution. In this case, it's lambda 1 plus lambda 2. So the variances added to each other, and then you get the square root of that. Okay? So what we end up with is the point estimate minus the plus or minus 1.96 times the square root of 234, which is the addition of these two, 234. Okay, just add them together. And there we get 12 plus or minus 29.98, which works out to be 17.98 and 41.98. So that is what our estimate is for the difference in rates. I mean, it sort of says that there's no conclusive difference between rates. And that is just a sort of based on how much data we have to work with, essentially. Okay, so that's it. We'll leave it there. That's the difference in rates. Is that actually it can be done the same way as a fairly conventional approach, but essentially all you have to worry about is the sample sizes, or in each case. Okay, and this is a particularly small sample size, but ultimately it still makes sense, or it's still mathematically plausible. Okay, we'll leave it there.